of H2S is also 0.05 mole per dm cube. The concentration in gram per dm cube of this is 4.90 gram per dm cube, which has been established in the earlier calculation. The concentration of H2S in mole per dm cube has also been established in the previous calculation. So in that situation, incorporating this formula to look for molar mass, the molar mass of H2S will be equals to the concentration of H2S in gram per dm cube, which is 4.90 gram per dm cube, all over the concentration in mole per dm cube, mole per dm cube. So at the end, we'll have, when this is divided by this, we'll have 98 gram per mole. So this is the molar mass of the acid H2S, which is 98 grams per mole. Questions designed for this topic, which is volumetric analysis. Number 1, which of the following can be used in an acid-base titration? A. Sodium sulfate. B. Sodium carbonate. C. Zinc carbonate. D. Potassium chloride. Number 2, what is the concentration in mole per dm cube of a solution containing 0.10 gram of sodium hydroxide in 50 cm cube of solution? Question number 3, what volume of 0.5 molar tetraosulfate 6 will exactly neutralize 20 cm cube of 0.1 molar sodium hydroxide solution? Question number 4, what mass of sodium triazocarbonate 4 should be needed to prepare 500 cm cube of a 0.1 molar solution? Question number 5, a molar solution of caustic soda is prepared by dissolving. Answers for this question. Question number 1, before a particular compound can be used for acid-base titration, it must be stable. It must be a stable compound, which is used as a primary standard because of the stability. Therefore, the only compound that is very stable and is used as a primary standard is sodium carbonate because of its stability. Therefore, the answer to question number 1 is B, which is sodium carbonate. Question number 2, what is the concentration in mole per dm cube of a solution containing 0.10 gram of sodium hydroxide in 50 cm cube of the solution? Mole per dm cube is also the same as 1 mole in 1 dm cube, which is 1000 cm cube. This is the standard units. In question 2, 0.10 gram of sodium hydroxide is dissolved in 50 cm cube. How many of these will you have in mole per dm cube? The first thing one is to do here is to calculate the number of moles of sodium hydroxide. Then the number of moles of sodium hydroxide is equal to mass of substance over molar mass. What is the mass of the substance? Mass of sodium hydroxide given in the question is 0.10 gram. The molar mass of sodium hydroxide is 23, which is for sodium, oxygen is 16, and hydrogen is 1. So if you sum this up, you're going to get 40 gram per mole. So in that situation, then the number of moles will now be mass of sodium hydroxide, which is 0.10 divided by 40, which is the same thing as saying, let's multiply this by 100 and this by 100. So here we have 1 over 4,000. 1 over 4,000 is the number of mole of sodium hydroxide. And since our interest is to look for the concentration in mole per dm cube, it means that 1 over 4,000 mole of sodium hydroxide gives 50 cm cube. We want to know the mole that will be responsible in 1,000 cm cube. Let this be x. Then we'll cross multiply. When we cross multiply this, and at the end we're going to have 50x equals to 1 over 4,000 times 1,000. So this cancels this. So this is 50x equals to 1 over 4. Then in doing that, x will now be 1 over 4 divided by 50, by dividing both sides by 50, which will now be, x will now be 1 over 4 times 1 over 50, which is the same thing as saying 1 over 200. And 1 over 200 is automatically the same as 0.005 mole per dm cube. So in a nutshell, 0.005 mole per dm cube is the answer. Question number 3. 0.5 molar of tetrasulfate 6 acid is given. Concentration of the acid, which is in molar. Then the concentration of the base is also given, which is 0.1 molar. What volume of 0.5 molar tetrasulfate 6 acid will exactly neutralize 20? So the volume of the base is given as 20 cm cube. And the questioner asks us to calculate the volume of the acid. The acid base titration is H2SO4 plus sodium hydroxide. This is acid base. And there you are going to have Na2SO4 plus H2O. This is, so the number of mole of acid is 1. The number of mole of the base is 2. using the acid-base titration formula, which is Ca Va over Cb Vb equals to Na over Nb, which implies that Ca is 0.5 times Va, that is what we are asked to look for, over Cb 0.1 times Vb 20 is equal to Na1 over 2, which is Nb. If we make this Va the subject of the formula, we're going to have Va equals to 0.1 times 20 times 1 over 0.5 times 2. When this is done, we're going to have 2 over 1, which is equal to 2.0 cm³. So this is the volume of the acid. The volume of the acid that is required is 2.0 cm³. Question number 4. What mass of sodium triisocarbonate 4 should be needed to prepare 500 cm³ of 0.1 molar solution? What mass? So we have 0.1 molar solution. So